Hi everyone. Note 6.1 are on periodic functions and their properties. So if you see right here, we have an example that I want to look at. It says, question number 1 says the number of hours of daylight at any particular location changes with the time of year. The table shows the average number of hours of daylight for approximately a 2-year period at Hudson Bay. But then it says, no, day 15 is January 15th of year 1, and day 74 is March 15th of year 1, and then day 411 is February 15th of year 2, where we're assuming that every year is 365 days, no leap years that we're looking at right here. Okay, so that should make sense to you. That day 74 is March 15th because January has 31 days. February would normally have 28 days typically, and then another 15 days for January, and that's how we get the 74 right here. For February 15th, we've got 365 days for the first year, plus 31 days for January, and then 15 days in February, and that's how we ended up getting the 411. Day 411 is February 15th, okay? So how many hours of daylight will there be on August 1st of year 3? Okay, so what we would do is we would take our table of values and we would graph it out. But for the sake of time, I have it graphed out for you so you can see what ends up happening. And so if you notice, the pattern keeps repeating. So every year, the days start off shorter, the number of hours of daylight is small, and then it keeps increasing, and then eventually it decreases, and then increases and decreases because we're looking at winter, and then summer, and then winter, and then summer, so on and so forth. Okay, so the question says, how many hours of daylight will there be on August 1st of year 3? So this only goes up to 714, and if I take 714, divide that by 365, that's still within the 2 years, and we want to go to year 3. So what we would need to do is we would have to extend our graph, but if we notice there's a pattern that repeats, we can just extend our graph easily without any issues. So I need to figure out August 1st is going to be day what? So August 1st of year 3, so that means that 2 years have gone by, and again, we're assuming each year is just a regular year, so 365 times 2, plus 31 days of January, 28 days of February, 31 days of March, 30 days of April, 31 days of May, 30 days of June, 31 days of July, and then 1 day of August. So if I were to add this all together, it would be 365 times 2 plus 31 plus 28 plus 31 plus 30 plus 31 plus 30 plus 31 plus 1, and I end up getting the 943 I want. If you wanted to, you could also do 31 times 4, obviously, but you guys hopefully know that. So right here, this would be on day 943. So again, it's marked on your paper here, but I just want to show you how we get that 943. So on day 943, I look at my graph and I see how many hours of sunlight there should be, and I would say that there should be approximately 17 hours of daylight, okay? So therefore, on August 1st of year 3, there should be about 17 hours of daylight. Okay, so let's do some definitions now. A periodic function is a pattern whose graph repeats at regular intervals. The y values show a repetitive pattern when the x values change by the same increment. So if you guys notice right here in our picture right here, from 0 to 365, we have these y values, but then from 365 to 730, the y values are repeated. It's the exact same, well, not exactly the same because this is not a fully perfectly sinusoidal graph, but it's pretty much what we're looking for. All right, so the period is going to be the change in the independent variable corresponding to one cycle. So essentially, how much time has gone by in order for a cycle to be completed. And if you guys notice right here, the cycle is going to be from the beginning of the graph until it starts to repeat the same value. So this right here is called your cycle, what I have highlighted in pink right here. So this is our cycle. And then the period right here is going to be how long it takes to complete a full cycle. Okay, so it's the value of the change in x, sorry, it takes to complete a full cycle. So here our period would be 365 days. All right, so the peak of your graph is going to be the highest point on a graph, okay, and that's called the max. All right, it's called the peak. And then the trough is going to be the lowest point on a graph, or your minimum. Okay, so when I take a look at what I have here, my peak is going to be right here. And that's going to happen during the summer solstice, right? And then the trough is going to happen here, and that's going to happen when we have the winter solstice, the shortest day of the year and then the longest day of the year. Okay, and then the equation of the axis is the equation of the horizontal line that is exactly halfway between the min and the max. Okay, so if you notice right here, if I wanted to graph out the equation of the axis would be halfway between my minimum and my maximum right here. Okay, so I'd find out what halfway is between those two, and then I would graph that out. Okay, now how do I actually find out a specific value instead of just guessing? All I have to do is y equals, because horizontal lines always start with y equals, the max plus the min divided by 2, because we're just finding the average of the minimum and the maximum to find the halfway point. Okay, and then the amplitude is just pretty much how far up it goes from the axis. So from the axis to the peak, and then from the axis to the trough. Okay, so the amplitude is the distance from the equation of the axis to the max or the min, and it's half the distance between the min and the max values. So to find this, sorry, not y, a is going to be our variable for our amplitude, and that's actually going to have be connected to our transformation value of a, and we'll talk about that later on in the future in this unit. So the a is the max minus the min, all divided by 2. Okay? All right, so let's apply this to a question right here. So question number 3, Tanya's mother works in a factory that produces tape measures. In the assembly line, a metal strip is raised and spooled onto a rotation cylinder contained within the tape measure. Tanya notices that the height of the end of the metal strip that attaches to the spool goes up and down as the rest of the strip is pulled into the cylinder. Consider the graph below that models the height of the end of the strip in terms of time, and then fill in the information in the table below. So the first thing I want to do is determine if this is a periodic function or not. So if you notice right here, it starts at a minimum, it goes up, and then it goes back down, and then we have another cycle where it starts and then it goes back down. We have another cycle, and it's continuing. We have the same cycle over the same period of time. So yes, it is periodic, and we're going to say yes, it's periodic because it's repeating the same values, the same y values at regular intervals. Okay, now I want to figure out what the range is. And remember, the range is your set of y values. So I'm going to look at my lowest y value and my highest y value, and it keeps oscillating back and forth between the lowest and the highest. So we're going to say right here, sorry about that, that h is an element of the reals such that h is between 1 and 9. So we're going to say 1 is less than or equal to h is less than or equal to 9. Okay, so our range is going to be anywhere between 1 and 9. All right, now to find my period, I want to know how long it's going to take to complete a full cycle. So right here, it goes up and then it goes back down, and I've completed a full cycle, and that took 0.25 seconds. And then it goes up and then back down, and it completed another full cycle. That was another 0.25 seconds. So my period is 0.25 seconds. Okay? Now, the peak, we kind of already figured out from our range, the peak is the highest point, right? And the highest point is 9 millimeters. And then the trough is the lowest point, and that lowest point is going to be 1 millimeter. Okay? Now, the equation of the axis is halfway between the max and the min. So to figure that out, I'm going to take my maximum and my minimum. I'm going to add them together, divide it by 2. So I get 10 divided by 2, which is 5. So I end up getting y equals 5 is the equation of my axis. Now, if I were to draw a picture of this, if I were to graph out the equation y equals 5, it would end up looking as follows. Let me choose another color. We'll do red. So if I were to graph out y equals 5, here is where y equals 5 would be. Okay, so if you guys notice right here, this y equals 5 value is exactly halfway between. So that is why it's my equation of my axis. Okay, and then lastly, to find the amplitude, I need to subtract the minimum from the maximum. So I do 9 minus 1 and then divide that by 2. So I get 8 divided by 2, or 4. So my amplitude is equal to 4. And that should make sense to you, because if this is 5 right here, to go from 5 to my peak right here is 4 millimeters, and then to go from 5 to my minimum right here is also 4 millimeters. So that's your amplitude. It's always from the center, how much it goes up and how much it goes down. Okay? All right, question number 4 says to determine whether the term periodic can be used to describe the graph for each situation. If so, state the period, equation of the axis, and the amplitude. I would like you to please complete question number 4 on your own, and then we'll take it up as a class. Please do not have a blank question number 4. I need you to think about it before you come to class. All right, I hope you guys have a great day, and I will talk to you soon. Bye.